Hi, my name is Megan and my project is investigating spatial patterns of distribution in cetacean strandings around Cornwall. Let's start with getting everyone on the same page. What is a cetacean stranding? A cetacean is a marine mammal in the order Cetacea. This includes dolphins, porpoises, and whales. A cetacean stranding is when the cetacean has run aground on shore and is unable to get back into the water unaided. Sometimes cetaceans that have died at sea and are washed into the shore are referred to as a stranding, but in this project, strandings only refer to animals that were alive when coming ashore. The reason for cetacean strandings can include natural causes, such as the cetacean growing too old or sick to navigate correctly. Often these have underlying anthropogenic causes, usually related to different types of pollution, such as plastic pollution. It's likely that an increasing amount of strandings are a result of increasing anthropogenic pressure. The British Divers Marine Life Rescue are a charity who rescue cetaceans that come into difficulty. They have 20 whale rescue pontoons in strategic points throughout the UK waiting to help stranded cetaceans. However, in order to determine those strategic points, it needs to be established where they will be most effective. In 2004, Dan Jarvis looked at hotspots in cetacean strandings between 1988 and 2004 around the Cornish coast. Jarvis identified 4 hotspots: St Ives Bay, Newquay to Perranporth, Mounts Bay, and Falmouth Bay. Although it's unlikely that these hotspots have changed in the recent 15 years, it's important to confirm this information. Also, if one hotspot has a higher number of strandings, it would be logical to have the equipment closer to that one to help reduce rescue time. My main hypothesis for this project was to confirm that cetacean strandings are increasing throughout the years. I wanted to know this because if strandings are increasing, then more equipment may need to be purchased. This project was carried out by combining 2 sets of records. The first was the BDMLR official database. Each rescue is carefully recorded in a nationally agreed way, which means strandings in Scotland have exactly the same information as strandings in Cornwall. However, medics do not attend strandings where the animal is already dead at the time of public alert. Therefore, stranded animals that died in places that were not accessed regularly, or events where the cetacean stranded overnight, would not be in their records. Therefore, the second set of records is from the Cornwall Wildlife Trust's Marine Strandings Network. They combine their data with post-mortem data, and this allows live strandings to be identified from animals that had died previously to being recorded. Once combined, the data was plotted onto an OS reference map of Cornwall and the Isles of Scilly. The map consists of 20 years of data running from 1999 to 2019 inclusive. Each point is for the stranding event and does not take into account the number of individuals. This was done so that events like the 2008 mass stranding, where 40 common dolphins stranded around Falmouth Bay, don't throw off the results. A statistical analysis split the map into 50-metre squared hexagons, which showed how many stranding events fell into each hexagon. An area of interest was one with 6 or more strandings. Looking at this data, you can see Mounts and Falmouth Bay are orange, showing they are still areas of high activity. They are both beside areas of yellow, showing that they are definitely areas of interest. St Ives Bay is red and the only red spot on the map. Either side of it is a yellow spot. Clearly, this is the bay with the highest stranding activity in Cornwall. Newquay to Perranporth has one yellow spot in the Newquay area. This shows that it does have some activity higher than normal, but not at quite the same level as the other 3. Using statistical tests, I tested the hypothesis that the total count of cetacean strandings was increasing each year. The results were an F value of 14.8 and a P value of 0.001, which shows that this is highly significant. When plotted, a line of best fit gives an R-squared value of 0.41, which tells me that 41% of the data fitted the line. This is also highly significant. The slope of the line was 0.55, which states that the total number of strandings is increasing by just over half a stranding every year. Looking at these results, the hotspots have remained the same throughout the years, with a possible decrease in the Newquay to Perranporth area. However, this could be not due to a lower number of strandings, but because my analysis splits the areas into 50 metres squared, and the coastline from Newquay to Perranporth is bigger than that. This means that my analysis would not pick it up due to the strandings being more spread out. The results also proved an increase in strandings. A lot of literature says that this could be an increase of observer and recording effort. Modern-day technology and an increase in public awareness did lead to an increase in strandings when compared to data in 1999. However, organisations such as Marine Strandings Network have been around since 2000, and with the iPhone now 13 years old, it's my opinion that technology is no longer responsible for the increase. Again, more investigation is needed, but majority of the increase happens from 2014 onwards, so future investigations should look at environmental data around this time. In summary, my investigations have shown that there are more cetacean stranding each year, and the previously identified hotspots are still prevalent. The next stage of my project will be to take a closer look at species strandings and combine this with possible temporal trends. Thank you for listening.